Here I want to introduce to you the main performance features in our new product DBOPTIMIZER 1.5. The two main performance components in DBOPTIMIZER are the profiling component, which is the little graph here, and the SQL tuning component. And I'm going to go through a quick demonstration of those two parts of the product working together. So DBOPTIMIZER works on 4 different database platforms: DB2, Oracle, SQL Server, and Sybase. I already have some targets defined here. I'm going to start with a Oracle database. So I'm going to connect to the database, and then we'll come up with browsing potential where you can look at tables, indexes, procedures, functions, etc. And once we're connected, which we're connected right now, I'm going to go ahead and monitor it. So I can just click on the profiling widget, and I get the profiling wizard, and I'm just going to take defaults and profile the database. So this database is idle right now, but I'm going to start up a load on the database, and we'll see what that looks like when it comes on. So right now the profiler is initializing. Here's the profiler, and it's empty right now. There's no load on the database, and I'm going to start up a load. So the profiler basically, it samples, here comes the load pretty quick. It samples every second the state of the users, and for every 5 seconds worth of samples, it rolls them up into an average. So then we have the average number of sessions active in those 5-second buckets. So as the load comes on, we can see things happening. It's just getting started right now. But we have 3 main areas at the bottom. So the top is the load on the database, which is the most important. That tells us whether the database is idle or whether it's busy or whether it's bottlenecked. Right now, the empty spots are idle areas. Green is CPU, where there's activity. And at the bottom is the top activity area. So we have top SQL, top events, and top sessions. And what we're going to look at here is the top SQL. So load on a database is put on by running SQL commands. So if we have a load on the database and we want to tune it, improve the performance, then we're going to have to look at the SQL that's the most active on the database. So right now we have one SQL statement that's taking up about 50% of the activity in the database, the select a.company. And it's super easy in DBOPTIMIZER to tune it. All I have to do is do a right click, and then I say tune. And it tells us the users that have executed it. I know my main part of my load is being run by Scott, so I'm going to choose Scott to tune that SQL statement. And now I'm in the tuner. And the tuner has profilers pass the SQL text from the tuner, from the profiler into the tuner. And right now I can go to the next tab. So it has 4 tabs: overview, generated cases, analysis, and outlines. In generated cases, as you can see, here's our progress bar down the bottom left. It's going to run through about 80 different Oracle hints and apply that to the SQL statement and see how many different execution plans it can come up with. And of those hints, it's going to run it through Oracle's Optmizer, get an execution plan for those hints, and see what the cost Oracle thinks those executions would be. Now, Oracle by default is going to choose the cost that's the cheapest. But if the statistics are wrong in the underlying tables, or if there is skewed data that might need histograms, or if some of the predicates are correlated, like how many Swedes in Sweden speak Swedish versus how many Swedes in Sweden speak Swahili, the difference is going to be huge, but the optimizers generally don't know about that kind of difference. So those kind of things can make the cost come out incorrect. So there might be other cases that Oracle doesn't find where the execution plan is actually faster for a case that Oracle didn't consider. Once we have all the generated execution plans, we can execute them. That's what this button on the bottom right is, and see which one's actually faster. So what we're most interested in is who's the fastest query. But other things that are important are physical reads and logical reads. Generally, the first time you run a query, there's going to be some physical reads, and then the executions of the query subsequent are going to benefit from those physical reads and do all memory reads, which are logical reads. But the easiest way to see the expense of a query is basically to look at the logical reads. So here we have a plus sign. We can see these are all the different hints it's applied. Now it's going to run through these different hints and see if there are any duplicate explain plans. If there are duplicate explain plans, it's going to throw out the duplicates and only keep one hint per explain plan. So all we're interested in are the different plans, not the hints the duplicate hints that produce the same plan. So once it compacts those, then we'll execute the statements, and I'm going to look at the logical reads to see which statement has the least logical reads. And once if we find a hint that works better, we have several options. One is we can add that hint by hand into our application, and that we'll have to do on DB2, SQL Server, Sybase, and we can do it on Oracle as well. Oracle also has the advantage of using stored outlines, which will store the outline in the data dictionary. So here's our distinct explain plan. So I'm going to run the queries, and then we'll see what the actual response time is and what the actual logical reads is. So we can see that, of course, Oracle, the default case, has the cheapest cost, because this is what Oracle thought would be the cheapest explain plan, the cheapest execution path. And when DBOPTIMIZER executes these different hints, if the execution path takes longer, a little bit longer than the base case, then we'll stop that case, because all we're interested in are execution paths that are actually faster than the base case. So we see that little blue X. That case was running slower than the base case, so we just canceled it and went on to the next one. And then we see the logical reads coming in here, and I can sort by logical reads. And I can see the first case here is 79,000 logical reads. And this hint here takes 8,000, so almost 10 times less logical reads. So we finished our executions. We found that this index fast full scan, index underscore FFS, is the fastest hint. It changed the execution paths and faster. So now with Oracle, I can go in and say, create the outline, and this will store that hint in the data dictionary, so I don't actually have to go change the SQL code itself. So here's all the code it takes to store that in the data dictionary. It's quite a bit of code, so it's super nice to have DBOPTIMIZER do the work for us. So I'm just going to say finish and let DBOPTIMIZER run those queries, which will store the hint in the data dictionary. So anytime somebody runs that query, Oracle will apply that hint that we found that was actually faster to the query. And once this hint is applied, we can go back to our profiler, see what the load on the database looks like, and see whether it improved or not. So it should have improved, but the question is, did it? Okay, now the hint's been applied, I'm going to go back to the profiling of the database and see what happens. So you can see that the load, which hasn't changed, has put a fair bit of load on the database. Now the question is, now that we've just applied the outline, what's going to happen? And we can see that the load on the database has jumped down. So this is a super easy way to see what the load is on the database. Find the top SQL. In this case, this top SQL here was taking up 58% of the database load. Send it to the tuner, and then ask the DBOPTIMIZER's tuner to automatically tune it for us, and then we can reduce the load. So we have a pretty good, so here's where we applied the hint, and you can see the load has gone down significantly. So I think it's super cool. Makes understanding what's happening on the database easy, makes tuning it easy. I don't have to be an expert at either understanding database performance or understanding explain plans. So it makes life easy for either the developer or the DBA.